All righty. Here we go. A couple of things. First off, you have a formative tomorrow in class, okay? And that one will be a full page one will be half. It's kind of like an inverse relationship. On the half page formative that you took earlier this week, you get all of the points back. On a full page formative, you get half of the points back if you need to fix something. Okay? So the reason behind that, the rationale behind that was we found over the last couple of years, we started it last year, but before that, we
when is like the formative to like the corrections?
Day of the test. Everything for us, due date for us is always day of the test. Yep. And so we found that people weren't taking the formatives very seriously, and they were just a couple people would just turn a blank one in or put IDK, which, by the way, if you never want to get points, put IDK. Okay. Yeah. So we switched it up to this, and so we're good to go with that. So let's do this today. Here's your warm-up. Through how many radians will the hour hand of an analog clock? This, by the way, is an analog clock. That, by the way, is a digital clock. Digital clocks suck for train because you can't go around and around and around on a digital clock. So we got to go back to an analog clock. Through how many radians will the hour hand of an analog clock rotate in 48 hours? Go. So on an analog clock, how long does it take for the hour hand to get all the way around? 12 hours to get all the way around, right? Okay. So 12 hours is one revolution. How many revolutions get made in 48 hours? 4. Each revolution is 2 pi radians, so then this would be 8 pi radians. Alright, love it. Good little warm up there. Alright, first off, let's convert 135 degrees, 47 minutes, 23 seconds into decimal degrees. And then also at the same time convert 78.435 degrees to degrees, minutes, and seconds. Pitter, patter. Let's do that.
It makes sense. My mom's not even. I don't need a ride, I just need to schedule it. Anything going on, you gotta schedule yourself. Except for now, legal adults. You just asked me how. Oh, did you figure it out? This factor label. Factor label.
That's what I got. Yay? Nay? Yay? I did. Good to go on that. All righty. Moving right along. Gunga-dunk. A 24-inch diameter car tire is making 9.3 revolutions per second. Find the speed of the car in miles per hour. Alrighty, so we're doing 9.3 revolutions per second. I know I need to be in miles per hour, so let's change seconds first. 60 seconds is 1 minute. 60 minutes is 1 hour. Okay, so now I'm in revolutions per hour. 1 revolution is 2 pi radians. 1 radian is 1 radius, and the radius is 12 inches. 12 inches is also 1 foot, and there are 5,280 foots in 1 mile. Quick check here. Seconds, seconds, revolutions, revolutions, minutes, minutes, radians, radians, inches, inches, feet, feet. All I got left on top is miles. All I got left on the bottom is hours. So this ends up being 9.3 times 60 times 60 times 2 pi times 12, all divided by 12 times 5,280. On 9.3 times 60 times 60 times 2 times pi divided by 5,280 gets me, I get that the car is, right word car, yes. Car is traveling at 39.841 miles per hour. What? No.
Oh, because we canceled.
That's why I only did 5,280 in the bottom. Okay. Yep. Still would have gotten this. Yes, ma'am.
Oh, would you stop this? Because I did, I put this 60 seconds over a minute and 60 minutes over an hour. I did that at the end. Does it matter or no? Like, it's not there.
Are you familiar with math?
Actually, let me double check.
What, if, more importantly, are you familiar with the subset of math called multiplication? The order matters in multiplication. So it doesn't matter. Earlier this week, somebody was saying, well, in science, they always take the top label and they get rid of that first, then they do the bottom label last. I don't care. As long as everything's canceling out, I don't care. Yep. Yep. Oh yeah, love it. What is the linear speed of the chain if the larger sprocket is rotated 4 times in 10 seconds? Okay. Linear speed of the chain. We'll get the visual out. There's the visual. Larger sprocket being rotated 4 times in 10 seconds. Speed of the chain. Okay? Go for it. Linear speed of the chain if the larger sprocket is rotated 4 times in 10 seconds. Let's come up with the same unit. Since it doesn't say what the unit is, let's come up with it. What unit do we want to get it in? Inches per second? Okay, inches per second.
Oh yeah, you're great. That sucks.
So we have 4 revolutions in 10 seconds. Each revolution is 2 pi radians. The radius of the larger sprocket is 4.85 inches. So that would put me at, revolutions gone, radians gone, that would put me at my inches per second that we had asked for. So we're going to have 4 times 2 pi times 4.85 divided by 10 is going to be on 4 times 2 times pi times 4.85 divided by 10 is going to be 12.189 inches per second. Yes? Okay. Now remember, guys, you guys are the closest one to the microphone. Okay? So whatever you say, just know it's going to be broadcast on the YouTube in an hour. Okay? All right? Okay. Agree with me on that? Okay, love it. What is the linear speed of the chain of the smaller sprocket if the smaller sprocket now goes around 4 times in 10 seconds? Again, we're going to go with inches per second. Yeah, we'll stay with inches per second. So once again, we are rotating 4 revolutions in 10 seconds. Once again, 1 revolution is 2 pi radians. But now 1 radius is 1.54 inches. So in inches per second now, we are multiplying 4 times 2 pi times 1.54, all divided by 10, which gets me 3.870 inches per second. Questions, comments, concerns, clarifications? Let's do this one. Under this bicycle setup, how fast is Lance Armstrong going in miles per hour if he is pedaling at a rate of 7 rotations every 5 seconds? So this is the pedal. The pedal is going around 7 times every 5 seconds. Okay? I want to know how fast he's going down the road. All right, here we go. So he is pedaling 7 revolutions every 5 seconds. One revolution is 2 pi radians. 1 radian is 4.14 inches from the pedal. Okay? So we're on the pedal. Okay? Remember, everything's got to be connected. So right now the pedal is going around and around and around. So we just found the linear speed of the pedal which is, or of the pedal sprocket, which is the linear speed of the chain. Yes? Okay. So now we can jump from the pedal sprocket to the wheel sprocket, correct? Okay. So now we're on the wheel sprocket, and that has a 0.81 inch radius, because that pedal sprocket is angularly traveling at the same rate as the entire tire is. Okay? This right here, the sprocket, is angularly traveling at the same rate as the tire. Okay? So now I am on the tire. The tire has a radius of 12.8 inches. So now I'm at the linear speed, or I should be. Revolutions are gone, radians are gone, inches are gone, radians are gone. I'm at inches per second on the tire, on the outer edge of the tire. So now I can change seconds to hours, and now I can change inches to miles. On top, I get 7 times 2 pi times 4.14 times 12.8 times 60 times 60. On the bottom, I get 5 times 0.81 times 12 times 5,280. Agree with me on that? Seven times 2, come on now. 7 times 2 times pi times 4.14 times 12.8 times 60 times 60 divided by 5 times 0.81 times 12 times 5,280. I get that Lance is going 32.698 miles per hour. Yes? On a wheel thinner than this. Thinner than these tires. Road racer tires are like not even an inch thick. Are they? Less.
That's pretty big.
Less friction. Questions, comments, concerns, clarifications? All right, so you should now be able to do everything in your homework packet. Your homework packet is wide open now for you to do. Okay? Okay? Tomorrow you'll be taking a formative. Tuesday we'll have a review activity. On Wednesday of next week, you need to bring your Chromebook. On Wednesday of next week, you need to bring your Chromebooks. Okay? Because the EMPT test is online. Okay? EMPT stands for Early Math Placement Test. It's the placement test that the UW system uses for their placements of incoming freshmen or of their students. We use it as a starting point, and then you'll take it again at the end of the school year, and we'll see how you improve at the pre-calculus, trigonometry type things.